We will now determine the parametric equations of the line which is tangent to the given curve equation at the points t naught equal to 0 for the first curve in part A, and for the second curve in part B, t naught equal to 2. So let's do the part A. I have copied the curve equation as like this, that is in component form like this. This basically represents the x of t, or we can simply write down this as x, and this represents the y of t, and then the next component represents the z of t. So first let's determine the point by plugging t naught equal to 0 or t equal to 0 into the each of the points, so that we get the point first. So I'm going to plug in t equal to 0 into each of these x t, y t and z t, which means this will be sine 0, and this will be 0 squared minus of cos 0, and this will be e power 0. So we get sine 0 is 0, and this is 0 squared minus cos 0 is 1, so it is negative 1, and e power 0 is 1. So basically we get the point. This is the point on the curve equation. So we have determined the point first. Now let's find the derivative of the curve equation. So therefore I'm going to find r prime of t. So we have to find the derivative of each of the parts. First let me do for sine t. Differentiation of sine t is cos t. Then I do the derivative of t squared minus cos t. So this is equal to 2t when you apply the power rule, minus derivative of cos t is negative sine t. We already have a negative, so this becomes positive sine t. And then derivative of e power t is e power t. So this basically represents the r prime of t. Now we have to plug in this value of t equal to 0 into this, so that we get r prime of 0. So let me do this. This r prime of 0 equal to cos 0, comma 2 times of 0 plus sine 0, comma e power 0. So let's evaluate this. This is equal to cos 0 is 1, and 2 times 0 is 0, and sine 0 is also 0. So this comes out to be 0, and e power 0 is 1. So this basically represents r prime of t at for the t value 0. Now to determine the parametric equations, we write down like this, that is x of t, y of t and z of t. Then we put the corresponding point in each of this parameter, that is this is the point 0, minus 1 and 1. So we put like this 0, minus 1 and 1, and then we put plus, we have to put the component or the coefficient for the t. So and for that we have to use the r prime of 0. So I can put this as 1 times of t, that is I'm using this 1, and then the next value is 0 times of t, and then the next value is 1 times of t. So why we have to do it like this is because we are basically using the parametric equation of the line. This is the line which is parallel to the tangent vector. So this is the point. I'm sorry, this is the point, and this basically represents a parallel vector. So that's why we do like this, that is we put the point over here, and then put the component or the parameter t with the parametric variable, parametric value. So finally we get 0 plus t is t, and this is negative 1 plus 0 t is just negative 1, and this will be 1 plus 1, 1 times of t is 1 plus t. So this represents a parametric equation, that is x of t equal to t, y of t equal to negative 1, and z of t equal to 1 plus t. So this is the parametric equation of the line that is tangent to the curve. We will now do the same procedure to find the tangent line for the curve given in part B. So let me copy the question in part B, that is I'm copying the r of t. This is equal to, I put this in component form, this is t squared and 2t minus 1. Next component is t cube. So first let's determine the point. For that we have to use the value of t naught or t equal to 2. So let me plug in t equal to 2 into this. So therefore I can write down the point as, if I plug in t equal to 2, this becomes 2 square, and this becomes 2 times of 2 minus 1, and this becomes 2 cube. So it is equivalent to 4. 2 times 2 is 4, 4 minus 1 is 3, and this is 2 cube is 8. So we get the point as 4, 3, 8. So we determine the point. Now let's move on and find the derivative of r prime of t. So I'm going to write down here r prime of t is, I have to take the derivative of each of the components, that is t squared first, then 2t minus 1, and then t cube. So the derivative of t square is 2t when you apply the power rule, and then derivative of 2t minus 1 is just 2, and derivative of t cube is 3t squared. Now we have determined this r prime of t. Once again we plug in back this value of t to find r prime of t equal to 2. So therefore this becomes 2 times of 2 comma 2, and then 3 times of 2 squared, and this gets simplified to 2 times 2 is 4 comma 2, 2 squared is 4, 4 times 3 is 12. So we get r prime of 2 equals 4 comma 2 comma 4. So basically this is the parallel vector uh, to the tangent. Now we can use this point as well as this parallel vector and construct the parametric equation of the line that is tangent to the curve. So let me write down as x of t, y of t, and z of t like this. And then I plug in the point first. So I'm going to plug in the point for each of the components, that is 4, 3, 8 like this, and then put the plus, and then I use the values from r prime of 2. So I put this as 4 times of t, that is for x of t. Then I take this value 2, that is 2 times of t. Then I take this value 12, 12 times of t. So therefore this is equal to 4 plus 4t. This is equal to 3 plus 2t, and this equals to 8 plus 12t. So this is the parametric equations of the line that is tangent to the given curve.